Now that we have sized our pipes and achieved the desired flow distribution throughout the system, we can begin the process of sizing a pump. FluidFlow includes an autosize feature for specific components, such as boosters, enabling users to define a controlled flow rate or pressure at a specific point in the system. The software then calculates and provides the information needed to size real-world components, including pumps and control valves. To define a duty point for our system, start by selecting a centrifugal pump from the component palette and placing it on the inlet line. In the input editor, enable the automatic sizing feature and choose Size for Flow as the sizing model. Then, specify a duty flow rate of 50 cubic meters per hour for the pump. After placing the pump, you will notice that the model now includes a suction side and a discharge side. We need to be careful here, though, as the discharge side was previously modeled as a single pipe. By adding the pump, the software automatically splits the existing pipe length into two. To rectify this, let's adjust the discharge pipe back to 30 meters. For the suction side, set the pipe length to 3 meters, assuming the pump station is located adjacent to the suction vessel or the tank. Now that we've defined the duty flow in our pump, we no longer need to define it at the inlet boundary. Instead, this node will represent the tank or reservoir on the pump's suction side. Let's change the inlet boundary node to a known pressure node, assuming the tank is open to the atmosphere. Additionally, we can give the tank a small elevation advantage to ensure a positive suction head for the pump. Before running the calculation, let's display some results on the flow sheet. In the dialog, select Duty Flow, Duty Pressure Rise, and Duty NPSH available to be shown. Once set, we can proceed to run the calculation. After running the calculation, you will notice that our flow distribution remains unchanged, ensuring that the required flow rate is still delivered to each offtake. We can look at the pump results and confirm that a duty point has been established. With this duty point, you can approach pump OEMs to select a suitable pump for the system. In many cases, a duty range, rather than a single point, will be specified during the design phase. You can investigate this in FluidFlow by adjusting the pump's design flow to simulate maximum, minimum, and normal operating flow conditions. Once the duty point or range is determined, you can replace the auto-sized pump with a pump model from the default database or add a specific pump model to the database for evaluation. This will allow you to assess the suitability of proposed pumps within the system.